So yesterday we had this triangle and it was basically like this. We had A, B, C, kind of like that. Then we were asked to fold it. So we folded it so that basically it flipped this over to there. So we folded it so that this landed over here, basically like that, kind of. Okay. So that's what we're looking at. So it ended up that then you had a new triangle because it was this triangle like this. This was the new triangle folded. And here's E and D. And here's, oops, that's not D. C and B. Okay, so we start out with a piece of paper, we folded it, and then we have this new triangle thing with several triangles on it. Okay, so so the pictures are always good for you to put down. The reason why pictures are really good to put down is because you can start marking them up the way you want to see them. Like I would call this side A, little a, okay? I would call this side over here little c. I would call this side B. Now we don't have B fully. We don't have C fully, but we do have this one right here. So I'm going to still label that as A, although it is also across from E. So you could call A and E are really the same thing. Okay, because this one was the same as A. This one now is across from E, so A and they equal. B is not the same because it's not the entire distance. We have a new point there, okay? And this is not the same because we don't have the entire distance there. But at least I can see that A and E are equal, okay? So, the first question says, on what angle did angle A fall? Well, on this one, we can see that angle A fell here on D, correct? The new angle it fell on was D. Because when I folded A, it came over here, that was D. It's not E, okay? And it didn't go up to B or C, so it fell on D. So 30 is just basically that it fell on angle. And this actually, you should be more specific because D actually has two angles there. Okay, so angle A, when I have it, it actually fell on this side, okay, of this. So angle BDE is where it really fell. It fell on BDE because that D's in the middle, but it's this top one right here that's the same as angle A. Okay, and so what we know is that angle A in our first drawing is actually equal to angle BDE. Because if you look at this, angle A, okay, you're supposed to be writing this down. That was part of participation today. So, everybody should be writing it down. So we know that angle A is the same as angle BDE because if it fell on that, then these have to be identical. Okay, because the A fell over there. Okay, so it says, in what way is angle BDE, what we just talked about, related to triangle DEC? So this is the triangle. So here we're looking at, so 31 is angle BDE related to triangle DEC. Okay. Now, let's just look at that. If you have this triangle, what is this angle? How is it related?
They're I can't remember what it's called. They're both angles on the line.
It's both angles on the line of one of the angles, so what's that called?
Collinear.
It's not collinear. In relationship, what other kind of angles do we have? We've talked quite a bit about this outside of a triangle.
It's a linear pair.
Well, it's also a linear pair, but in relationship to specifically this, what is it? So if I drew this triangle, let's just draw it separately now. Here's EDC, and I have this angle right there. That's the angle we're talking about. What is that? Think back on what we've been working with. What is that?
Is that the hypotenuse?
No.
Exterior angle?
It's an exterior angle. Okay, you should be able to recognize exterior angles, right angles, all that kind of stuff. You need to be able to, yes, it is a linear pair with it, which is the definition of an exterior angle. Okay, because it has to form a linear pair. So this is actually BDE, angle BDE is exterior. Okay. I think yesterday when some people were answering this, they didn't realize this said triangle. You have to really be careful when you're reading it. So really read carefully. Okay. Another thing I do is sometimes I draw out from the picture. I just take it out of the picture because the question was, how does this angle, this was B, how does BDE work with this? So I just draw that. I see that that's an exterior angle much easier, okay? So I think sometimes making or pulling the information out, looking at the triangles differently helps us. So don't be afraid to pull something out of the drawing. I just took that angle and this triangle and put them here. Now, I know my drawing's not exact, but it really doesn't have to be sometimes because sometimes we're just trying to get the idea of what is it, okay? So another hint is when you're doing these problems, draw a portion of the picture to see info more clearly. So that's what I did right there, was I drew from that picture part of it so I could see what are they actually asking, okay? And sometimes that's good for us. We have to see things. I'm a really big sight person, so I have to see it because sometimes this gets me all confused when I'm looking up there. But when I actually pull it out and look at, oh, yeah, that's an exterior angle, okay? Okay, so number 32. What does this relationship show us about angle, so 32, and they're referring to this relationship, the exterior angle relationship. It says, what does this relationship show us about how angle BDE compares with angle C? So angle BDE compares to angle C, okay? So right now we're looking at this, angle BDE and angle C. What do you know about that relationship? An exterior angle is what?
Probably bigger than the other angle.
It is. An exterior angle always equals two of them. Remember? It equals this one and this one. Because if you think about this one is what's here. So the exterior angle to make because it makes 180 and these make 180, it is equal to both of these added together. So we know that angle BDE is greater than angle C. That's what we can figure out from here. Okay, that's what they're looking at. So again, I wrote down what exactly do they want. Okay, here I wrote down what exactly do they want. Because sometimes we have to write those things down for it to click in our minds what they're actually looking for. Okay, so then we get to 33. Okay, 33 says, what theorem does this experiment oh, I didn't actually assign 33, did I yesterday? No, I didn't. Okay, so we're going to skip 33. It actually just talks about the exterior angle theorem. That's what it's talking about. So it's the exterior angle theorem. Okay, so 34 is the next one I signed. Okay, and it says, what does the fold line BE do to angle ABC? So we're looking at DE, okay, and what it does to angle ABC. So I want to actually, was that DE? That's not right. BE. I knew that was not right. Okay, BE. So if I fold this right here and I fold it across, so we're back to this. What is this line? BE. Where I folded it, because that's the new E. So I'm actually back to this picture. What does that line, when I fold it, do to angle ABC? What does it do?
It bisects it.
It bisects it. When you fold a piece of paper in half and you have one angle that you're doing at, it actually bisects, because you're doing it to fold it in half. Okay, so it bisects it. So this is BE bisects angle ABC, okay? 35. How can your answer to exercise 34 be used to prove that angle BDE equals angle A? Oh, okay, that's pretty easy. So what we want to say is that BDE equals angle A, okay? Well, let's go back to this picture now and look at it, okay? We know some things. This side is going to be, because if I fold these in half, those two sides are going to be the same, correct? Does that make sense? If I folded this over here, that side's going to equal that side, because when I move it over there, it's going to be that distance. Okay? They share a common side. Do you see that? Okay. So there's two triangles, ABE and let's see, BDE. Let's see, ABD, it would be DBE. Okay. Well, what do I know about these? We just said this bisected it because it. So what can I say about these two triangles? Are they congruent? How do we know?
Because BE bisects it.
Okay, and what else? We know there's.
Angle A equals.
Can't you use side angle side?
You could use side, angle, side, because we have angle or side AB equals side BD or DB. Okay, we know that angle ABE equals angle DBE. We know that BE is equal to BE. So that would use side angle side. Okay. There's actually another way. What else could we use if we don't want to use side angle side? There's another way we can actually say it.
Angle side angle?
Yes. Okay, now when you say angle, side angle, or SAS, you should show me which ones you know are true. Okay, now on this one, you can, I should have done this, okay? You can use your marks, but that one's not, that's one mark. Okay, so this is one mark, that's one mark, these are equal, and that's equal. Okay, so you can refer to them. You can say refer to drawing, and you look at, okay, this angle, this side, so these angles, this side, and this angle all are congruent, so we can use ASA. But you must have it marked, otherwise you have to write it down. Does that make sense? You need to prove these, you either need to have marks on the triangles showing their relationships to each other, or you need to write the equal parts. Okay. If you're like me, writing the equal parts is a pain in the butt. Okay. I would recommend that you try to mark it on your triangle. Okay. Does everybody have this written down? These are things for you to, I'm telling you how I want you to do things. So I'm not seeing everybody writing all this down. Are we getting this all down? Okay, so these are ways, so I'm trying to give you a couple hints on how to do problems. If you need to draw a portion of a picture, do that. It helps, okay? When you're looking at questions, make sure you read it very carefully. Know what it's asking, okay? What is it asking here? Okay. And then when you get down to say that two things are equal and you have to prove it using triangles, because we're looking at BDE equaling angle A. Well, we've already actually proven that, so I guess we can't use ASA because we're trying to use that in it. We already proved that because when you fold this, it's the same angle. I don't know why they actually proved that way. Okay, anyway, but you either, my big thing is you either have to have tick marks or you have to explain why there it's SAS. Just don't say SAS. SAS because the three reasons. Or SAS because look at drawing for tick marks. And that way we can see, okay? So those are the kind of things I'm really, helping you to try to go through. It's nice if you just write part of this on your paper so I know what you're trying to find. And it also, when you write it, it makes it better for you to review or to know what you're asking. Because sometimes we lose it in the midst of looking at the triangle. We lose what we're trying to figure out. So if you write down what we're trying to find there, I think that is something that's, very, very positive to do. So it helps you. So, questions on that?